When a computer or a physicist attempts to solve a product of antisymmetric tensors, they must sift through a vast field of possible index combinations. Most of these combinations result in nothing, the equivalent of mathematical silence, because the inherent nature of the antisymmetric symbol acts as a rigorous filter, zeroing out any arrangement that contains repeated information. A discrete step occurs only when the system encounters a perfectly unique, valid permutation. At these precise moments, the running total jumps upward, ignoring the surrounding noise of zeros. These jumps represent successful hits, where the internal components align perfectly to contribute to the final result. The transformation highlights a dramatic shift in computational effort. In a three-dimensional space, one must investigate 9 different internal combinations just to determine a single outcome. This loop-based approach is inherently complex, involving constant sign flipping and twisting operations. By identifying the final constant, we can bypass this exhaustion entirely. We replace the tedious process of checking every permutation with a direct scaling operation. This effectively restores symmetry to the problem, proving that what appeared to be a complex sequence of rotations is actually just a straightforward identity multiplied by a specific factor. The final value that the running total reaches is essentially a permutation counter. This number represents the degrees of freedom, or the various valid paths available for internal indices to arrange themselves without canceling out. As we move into higher dimensions, the number of these valid internal paths grows factorially because the complexity of potential arrangements increases. In 2 dimensions, there is only a single non-zero path for the shared index to follow, resulting in a scale of 1. In 3 dimensions, the internal space allows for 2 distinct arrangements, and the total climbs to 2. By 4 dimensions, the degrees of freedom expand further, requiring the running total to make 6 successful hits to reach a final constant of 6. These final constants and their corresponding symmetric scales have deep roots in how we perceive physical space. The single path found in 2 dimensions is geometrically equivalent to a vector projection. The 2 paths of 3 dimensions form the basis for the famous triple product identity, often used to describe electromagnetic and fluid forces. The 6 paths of 4 dimensions represent the scaling of a hypervolume, reflecting how antisymmetric components align to measure space in higher reaches of physics.